Hello, everybody, and welcome to the Monday edition of Advent of Code in Kotlin, the 11th out of the 12 streams that we've been doing this year. Time really does fly when you're having fun with coding challenges. So I'm, of course, very glad that you have once again decided that you would spend your afternoon, your evening, or your day with us. And I think we have a little bit of Kotlin-related puzzling to look forward to today. So, as usual, if you are joining us for today's stream, make sure you say hello in the chat. I already see the first couple of people showing up here. It's very delightful. It's also very delightful to see a couple of people sticking around. Johnny or Rob, who've already tuned in for a couple of other streams. Rebby, who's come in with an awesome solution yesterday as well. Dave, our a guest from one of the previous days. It's an all-star cast in the chat out here. It's already really great. How did it go today? How was today's puzzle for everyone? Still have to say, waking up at like 6 in the morning, doing these puzzles like half asleep in bed. It's a good time together with the winter wonderland outside. Rebby says too easy. Okay. All right. Sounds like someone had the correct tools at their disposal. Rob says glad I didn't brute force part 1. Okay. Because of the Monday type puzzle. Well, maybe. You know, sometimes it's also nice to start the week with a win. Yeah. It's a lot of fluctuation in the difficulty levels going on. But yeah, I think despite all that, we certainly have a bunch of different things that we can talk about during today's stream. So, just like for the previous days, I am not doing this alone. Instead, I do have a wonderful guest who will bring their perspective on the problem and on Kotlin. So, I'm really glad to introduce to our wonderful little cozy stream here, Svetlana, my colleague, also fellow Kotlin developer advocate here at JetBrains. Hi, Sveta, how are you?
Hi, everyone. Hi, Seb. Hello to these crazy people who watch our live streams after so many days still watching. I'm really glad that you're with Kotlin and Advent of Code.
Yeah, I have to
Crazy
say, I'm really excited that we have this little community of people who just all like hang out and all in the pursuit of learning and puzzling. You've done Advent of Code in the previous years as well, right?
Yes. My best year was when I have a baby, and I was really tired of this first month of thinking of doing all the baby stuff. It's like, I want to go back to, but no, slowly. And it's like, Advent of Code was perfect timing for it. So doing some puzzles.
Did that help with doing the puzzles right in the morning, or did you decide to do them on your own
schedule?
Actually,
I never did this competition stuff. I never did the early morning, getting up stuff. I always did that in the evening or whatever time I can find. And with kid, it's like, it's hard.
Yeah, I can imagine.
Find any time. Yeah.
As a late owl, it's hard enough without a kid getting up at 6 to go straight into the puzzles. But yeah, for context, you are in the same time zone. You are even in the same city as I am, so the puzzles for you also unlock at 6 in the morning.
Actually, kids help to get up early but they don't really get help to this. But it does help to finding more time to solve puzzles.
Oh yeah, that I can very much imagine. Yeah. So we do of course have a puzzle to get into today, but I was just informed prior to the stream that there's still a couple of spaces in our Advent of Code in Kotlin leaderboards left, specifically on the 7th leaderboard. So if you have not joined any Advent of Code leaderboard yet, you can do that. You can head over to the leaderboards section, then go to private leaderboard and add that leaderboard. Please only join one of them though. So if you're already in leaderboards 1 through 6 somewhere, no need to join the 7th one. It's also important that whether you are doing the challenges very early in the morning and are competing for like a spot at the very top of the leaderboard, or whether you decide to do them in the evening or a couple days later or on the weekend, it doesn't matter. You actually have the chance to win some cool Kotlin swag regardless. So make sure you take a look at that. I'll also post that link over here. Andy asks, can you talk a little bit when and how the prizes will be announced? That's a great question and a very fair question. So first of all, one of the important things is that we have a way to contact you in your GitHub profile. Sometimes we've also had people ask whether we also support GitLab instead. If you happen to not want to use GitHub, you can DM me on the Kotlin Slack, and you can send me your GitLab handle, and I'll make sure that we add it in the drawing. The drawing will happen sometime in January, because people will, of course, continue working through Advent of Code all the way until the 25th, regardless of our streams, which will sadly only continue one more time tomorrow. The prizes itself are a little surprise, but as Xenia has put it so nicely, it'll be some Advent of Code in Kotlin swag in one form or another. Maybe there'll be wild glitter rainbow unicorns. That would also be very cool. So yeah, make sure you take a look at that blog post if you haven't yet. Join our lovely little community and hang out there. Have you joined the leaderboard, Sveta?
Nope.
Okay, well, there's still space in the 7th one.
I'll consider it. Thank you.
Yes. Also, before we dive right into today's challenge, I do want to note that for you folks who might want to tune in for the last stream of the year tomorrow, we will be starting a bit later than usual. And that's because the live session on Kotlin and WebAssembly will be happening at 5 p.m. UTC, or Central European Standard Time, will be happening here on the Kotlin YouTube channel. So you can watch that first, and then you can join us afterwards. And it'll be a double feature. The speaker will be Salim, who you've actually already seen on the Advent of Code streams, who's demonstrated one of them on the previous days, because Kotlin for WebAssembly is now in alpha, which is quite exciting. All right. Well, I think that's most of the logistics out of the way. And I think it's time for us to take a look at today's puzzle and start discussing that. So, did you have any wish for the puzzle that was gonna come on for the day where you were gonna present, Sveta?
Not really. Probably just something that I can solve and explain.
Fair enough. Yeah. I do personally, I really always do enjoy the graph problems. If only they don't usually get, if only they wouldn't get so hard in the second part of the problem. So
now I'm thinking about it. I like when I can add some visuals to explain something. I'm a very visual person, and I always like some, I don't know, drawings or diagrams or schemes. I don't know whether I can draw something on every puzzle, but this one certainly gives plenty of opportunities to explain something in diagrams. So in this
Okay.
case, yep.
Then I hope that we'll see some
It's actually
diagrams
really well.
later.
Probably.
Awesome. Cool. So, without further ado, let's dive into day 11, Cosmic Expansion. You continue following signs for hot springs and eventually come across an observatory. The elf within turns out to be a researcher studying cosmic expansion using the giant telescope here. He doesn't know anything about the missing machine parts, he's only visiting for this research project. However, he confirms that the hot springs are the next closest area likely to have people. He'll even take you straight there once he's done with today's observation analysis. Maybe you can help him with the analysis to speed things up. The researcher has collected a bunch of data and compiled the data into a single giant image, your puzzle input. The image includes empty space, dot, and galaxies, hashtag. For example, this image. The researcher is trying to figure out the sum of the lengths of the shortest paths between every pair of galaxies. However, there's a catch. The universe expanded in the time it took the light from those galaxies to reach the observatory. Due to something involving gravitational effects, only some space expands. In fact, the result is that any rows or columns that contain no galaxies should all actually be twice as big. In the above example, 3 columns and 2 rows contain no galaxies. These rows and columns need to be twice as big. The result of cosmic expansion therefore looks like this. So now for every row and column that is marked here as being empty, you'll notice that there are 2 rows and columns in the expanded version. Equipped with this expanded universe, the shortest path between every pair of galaxies can be found. It can help to assign every galaxy a unique number, like 1 through 9. In these galaxies, there are 36 pairs. Only count each pair once. Order within the pair doesn't matter. For each pair, find any shortest path between the 2 galaxies using only steps that move up, down, left, or right, exactly 1 dot or hashtag at a time. The shortest path between 2 galaxies is allowed to pass through another galaxy. For example, here is one of the shortest paths between galaxies 5 and 9. This path has length 9 because it takes a minimum of 9 steps to get from galaxy 5 to galaxy 9, the 8 locations marked with a hashtag, plus the step onto galaxy 9 itself. Here are some other example shortest path lengths. Between galaxy 1 and galaxy 7, 15. Between galaxy 3 and galaxy 6, 17. Between galaxy 8 and galaxy 9, 5. And that's it. In this example, after expanding the universe, the sum of the shortest paths between all 36 pairs of galaxies is 374. Expand the universe, then find the length of the shortest path between every pair of galaxies. What is the sum of these lengths? Okay, wonderful. So, Sveta, when you read this description, what were your initial thoughts?
Let's code it.
Let's code it?
No. Actually, I think I read it on my phone. The first moment I woke up, I was like, okay, now I should read the description. I immediately started to understand how to calculate the the new coordinates after expansions.
Okay. All right.
So it's like that. You should just sum up the added values and add it to the initial value, something like this. But let's probably dive into details more slowly.
Okay. Well, should we go right into your code?
Yeah. We can first go to the code to see some setup, and then go to slides to actually see some diagrams, promised diagrams.
That sounds great. Then,
Yeah,
so just like in some of our previous days, we are back in Feed. And Svetlana is just connected to my machine using the collaboration mode. So while all of this is running on my machine, Sveta can still control things, she can run things, and she can move around. Speaking of, I should probably, or we can probably slightly zoom the IDE a bit more, just for the text. Does that fit all lines? It does. Great. Then we'll do it this way on maximum. Great. All yours, Sveta.
Yeah. If it doesn't fit the lines, we can put enter on a line and have 2 lines.
Yeah.
So I prefer to reuse the titles from the task description, just not to invent my own titles, even for simple stuff. So that's why we have data class Galaxy with coordinates. And then we can see how like the logic is implemented. But first, I don't think that we should repeat the regular stuff when you just print you just read the input and read the line, and then what I do, I put it pass these lines into image class that represents an image of our galaxies before expansion. Then we'll see it a bit further. We do expand image and have the resulting galaxies after the expansion, and finally we find the result using by some of these paths between new galaxies. But first, let's see how we build this image. We have, as I've told, input list of strings, so it's like our lines that we have as our either sample input or resulting input. For me, it's just more convenient if I prepare this width and height beforehand in order to use them. So it's all utility preparation work that might be skipped, but I prefer being explicit in and have probably sometimes even more functions that you might need. But again, this improves readability and it's easier for me to understand what's going on.
I think that's why is particularly useful because you're kind of working with a rectangle with like a list of lists where every list is the same length, but that doesn't become super clear if you're just using input first length like at the usage sites everywhere. So packaging that nicely into just a width, I think is a really nice move.
And this solution is a bit different from what I have for part 1, because I think that whoever does very regular advent of code, they immediately declare type long, probably just in case. And in my case, I was like, okay, let's start with int. And afterwards, yes, I probably should replace it, but it was easy because it's just one file solution. I just replaced all occurrences of int, and then the only places where I need to convert is here. But we expect, that our input conforms to int type, for sure. So then, again, to improve understanding, okay, we can probably, then we have these warnings that these functions might be private. Okay, let's keep them private. So I have explicit function checking that these coordinates represent galaxy. And something else that I want to be very explicit at is just I have a separate function for the reverse as well, for checking that it's not a galaxy. Yeah, so in this case, it's just we are checking that the corresponding symbol is a hashtag. Then what I need, I want to at first build input list of galaxies where each galaxy contains its coordinates. So what I do, I use function build list that at first if I start typing, I need to specify the type, but now it's like, or I can just type and afterwards compiler understands that it's list of galaxy. So here I iterate over all the coordinates, and if it's a galaxy, very straightforward, I add such galaxy to a resulting list. Again, for me, it improves readability, and also when I develop, I can print the output and check that, yeah, it corresponds to the galaxies that I have in a sample input. It's also convenient to be able to see that. So it's like this is the step that I print out to see what's going on.
I think what's nice here, by the way, also for people who are maybe actually veterans of Kotlin is that you're to create these ranges, you're using the range until operator, the dot less than, which was only introduced a couple of Kotlin versions ago. It behaves the same as until, but it allows you to use the same kind of like range syntax rather than use an infix function, which is quite nice.
It was a special pleasure, actually, to be able to use this operator in real life. Yes, absolutely. So before discussing how we perform the expanding mechanism, probably we can switch to slides and discuss the concepts.
Okay.
There. Yeah, so we already have like the basics that we have, like this is galaxy, is empty space functions that we're going to use very soon. So we are using this multi-presenter slideshow in Keynote. It turns out that Keynote allows us to do it, which is really cool. Okay, control. Okay, seems it works. So let's discuss now how we calculate expanding rows and columns. So we know by our task that some of the columns expand and some of the rows expand. And it is very straightforward how to find a column or row that needs to be explained is just the row that or column that contains no galaxies, no hashes. We can implement this logic. It takes a bit of carefulness to use all the indexes correctly, all the height, width, sizes correctly, because I think that source of bugs will be just mixing up something and not that carefully. Yeah, but if doing it slow and with diagrams, it works. So in this case, we have expanding columns. Those are columns that contain no hashes. So what we do, again, a fan of explicit and of sometimes defining one more function to emphasize what I'm doing, other than writing all the code, even the correct one, all the code together. In this case, it's also easier to find bugs and find possible mistakes. So in this case, I define function isExpandingColumn that just checks that the corresponding column doesn't contain any hashes. Again, this new operator, new until. Do you have a name? I forgot.
It's a range until
operator. Range until operator. Yes, range until operator that was introduced recently. After I defined this function that checks whether this specific column is an expanding one, For my convenience, I want a list of all the expanding columns because I will use a list of all indexes of all the expanding columns because I will use these indexes afterwards. So what I do, I just I use filter on a range of all the x indices, and for each index, I just check whether it is an expanding column or not. And if it is, this index goes to expanding columns. In this case, the resulting variable expanding columns will contain list of 3 numbers, 2, 5, and 8. The same goes for expanding rows. In this case, I just need to carefully replace x with y in all the correct places and with 8 in all the correct places again. But the idea is very similar. Again, the function that checks whether this row is expanding, meaning doesn't contain hashes, and building the list of indexes of expanding rows. In this case, this variable expanding rows will contain the value 3 and 7 for me. So it is, again, some kind of util preliminary actions to be able to perform this expansion operation. That is the core of this task. So now let's discuss how we calculate coordinates for every galaxy after expansion. Again, I want to split this task into parts. And in this case, I want to calculate the coordinates for one particular galaxy. And after we calculate it, we can, of course, perform this operation for every galaxy. So as an input, we have a galaxy. So again, this is the visualization of what we want to do. We have a specific galaxy marked marked in the image by rectangle. And after expansion, we are interested in new coordinates of this galaxy. We call it new galaxy. What do we need to do to calculate it? So we can calculate separately, of course, x and y. And for instance, here we see that when we're talking about all expanding rows, some of these expanding rows affect the final y coordinate of new galaxy, and some don't affect it. Those that affect the final coordinate are on this image kind of above the galaxy. So everything that is above among the expanding rows affects the final coordinates. What I do, I calculate delta that needs to be added to the initial coordinate to find the final value. And during the stream, you understand that's probably not the best name, but it's too late to. We unfortunately don't have refactoring in slides, so I'll have to live with this for the time being. So that basically means how many rows affect the final coordinate. And we take all the expanding rows. Again, this is the list of just indexes. And for each index, we check whether it is less than index of galaxy. And if it is less, then we count this index into the resulting affecting expanding rows that have an impact on the resulting value. So in this case, in this example, the result will be 1, because 3 is less than 4, but 7 is not. So only the row above impacts the resulting value. And we do the same with columns. Again, we should be very careful in our calculation. It's like drawing carefully and understanding what's going on. Here, 2 columns affect the resulting index after the expansion. but we do basically the same check. We get the expanding columns list that we pre-calculated beforehand for us, printed out to make sure that we calculated correctly. And now we can use the value. In sample example, it's 258. And when we check which columns affect the resulting galaxy, we see that 2 columns affect, and the result for my x delta is 2. And then we need to calculate the resulting position of the new galaxy, because these columns and rows expand. So we should add the corresponding the corresponding extra columns and rows to index. Let me see. There is, yes, I repeat what we already did. So we calculated these 2 deltas for x and y. And now we can calculate the new position of the galaxy, the position of new galaxy after the expansion. So here we need to add something to the initial value. So initially we have x and y, and we need to add some numbers of rows and columns. And for the first part, and how I wrote initially the solution for the first part without this expansion coefficient, because there were no expansion coefficient. We just added an extra row to each row. So it's like we doubled each row column. So in this case, if we say that, so it is part of the sample output, and we are considering the first column in a sample. In the first part, it was doubled. So it's like we added 1 more column to the image. And because we're adding 1 more column, we need to add 1 more column for each column that affects the result. So for each column that we calculated in this x delta, we're adding 1 extra column. And for each row that we calculated in y delta, we are adding exactly 1 row. So that's why for the first part, the result is just summing up x and x delta and y delta. So this part is straightforward. We're just adding the same. So it's like for each columns, we just add 1 more column to the result. And if we think about the part 2 case, when we have a coefficient,
We haven't seen part 2 yet. How would we know?
We haven't seen it yet. Oh, how would we know? Yes. Oops.
It's all good.
We can I don't know, go back and check the solution, or
yes, let's do that, and let's also compare it briefly with what I had. So no spoilers here. But all right. Okay, so where did this code end up in your
is just below exactly what we have. We have here is expanding columns, as I showed you. Mm-hmm. Just copied. Here is 1 line, but in the slides it's like more than 1 line. The same with rows, and we have this expand image that does the separation for each galaxy. So here we calculate deltas, and we calculate new galaxy in the code. I can name it expansion coefficient in long, but here's exactly the code. And for the first part, my code is just this without any coefficient. I just add x and x delta.
Okay.
And thing I don't cover in the slides, but it's pretty straightforward. For each galaxy, I need to add a position after coefficient. I don't know why I don't use map here.
Well, that's a great little refactoring to still make, I suppose.
Yes, can we do it automatically? Oh yes, nice. Okay.
There we
No,
go.
you haven't seen the code before.
Beautiful. Look at that. Yeah. So this was this the first thought that you had right when you went into part 1.
Yes.
Okay, that's great.
That's
For me,
that's exactly.
I took a little bit of a step back, and I think one of the things that's first of all is important to kind of understand here, is I think having the this mentions a lot of things about pairs and like shortest paths, so it might be tempting to think about it might be thinking to do things like hey, maybe I need to do like Dijkstra or something because you like remember that it's like single source all shortest paths, like these kind of things, and then you're like, maybe it's all sources shortest paths algorithms, but as you can see, there's actually a much simpler approach here. Actually, the part that we haven't quite covered yet is how you generate or how you go pairwise across each.
Yeah, the result.
Yeah.
Yes. So what we can do, we can understand first that when we are interested, or it's like the solution. The description says count each pair once, but if you just calculate all pairs, then in this case, each pair will be calculated twice. And in this case, we can just find the sum between all possible pairs and divide by 2, because the path between each two galaxies is the same independently of which one is the first one, which one is the second one. So here we just need to map all, like we need to find all pairs and find the sum of using shortest path and then divide the result by 2. And if we're talking about shortest path, my first so it's like when I saw the description, I was like, okay, you just need to calculate the coordinates. I wasn't sure whether you need to +1 or -1 somewhere, because it's like, oh, what will be? But it was obvious because there was just, and also when reading the first part, I was curious, would the second part contain the different expression, or it would say you should avoid galaxies, because avoiding galaxies would be much more difficult task to solve.
Oh, very good. Yeah.
And I don't know. I think it's a really complicated problem to solve. But luckily, it probably goes some other day, or another edition. Yeah, but
another part that your code actually exploits here is you're not only pairing everything up, you're also pairing each galaxy with itself. And you're calculating the shortest path for that as well, which just happens to be 0, which is lucky that you're doing a sum and you're not doing a multiplication of all those results.
Yes.
Otherwise, that would be
we're just lucky. Yes, in this case.
Yes. And then the actual calculation of the shortest path, you just do the absolute difference between the x's and the y's. And I actually have a tiny little couple of slides up here that maybe give us a little bit bigger of an insight of why that is to be the case.
Okay,
yeah, I know. So the thing is that thanks to the constraint that you're only allowed to move north, west, east, and south. Like this is the kind of path that they draw in the example. You'll quickly realize that this path is equivalent to, let me just see if I can forward my slides. There we go. It's equivalent to this path. So these two paths are the same length. It's also equivalent to this path. So it's always just a matter of the differences in x coordinate and y coordinate. And this Jonathan has mentioned this. This does have a name. it's either called the Manhattan distance or the taxi cab geometry or taxi cab distance, which is just a distance measure where you're only allowed to go left, right, up, or down, and you're not allowed to do like diagonals. And you will see here that it actually does specify in formal terms that the taxi cab distance between 2 points is the differences of the x absolute value of that plus the difference of the y's and the absolute value of that. So, and that's exactly like the code implements exactly the same thing here. Now, still for part 1, there is actually a different approach that you can take. Rather than just offset the galaxies, what you can do is really just expand the space. So we can take a quick look at my solution here, and we can take a look at my part 1. So I also just read the I just read the input text, and then in a very similar way to Sveta, I compute my empty rows and empty columns. This is essentially just inlined and with fewer names, so that it becomes more cryptic. So first of all, we look at all the indices of our lines, which essentially just means those are all of our columns. This is the width of our of our map, and then we'll say if in that column everything's a dot, that makes it an empty column. And for the rows, it's kind of the same thing. We'll go through all the lines and or all the indices of the lines, and if they're all dots, that makes them empty rows. So for me, I decided, okay, we can write this out as a nice little function chain. We can say we'll take our lines, we'll apply some expansion function, which expands the characters at empty columns and empty rows. So this happens on the string. You'll see that after this, I have literally transformed the input list of strings. Then I'll kind of do the same thing that Sveta does, which is translate every hashtag into a galaxy object with coordinates. I have a special combined pairwise function that we'll look into in a second. We'll then compute the shortest paths and sum them up. So the expand function for me looks like this. Fits exactly on screen. Isn't that delightful? So really all it does is it rebuilds... Oops. Okay. It rebuilds the string kind of from scratch with the changes applied. So what we do is we build a list of strings, so those are our individual lines, and then for each line, we do some kind of expansion. This expands the columns, so every time we encounter a column that's supposed to be expanded, we turn the individual character into 2 characters. Otherwise, we just return the original character, and then after that, we join all of these individual characters back together as a string, which is very much non-performant, but you can do this. That works. And then you do the same thing in the other direction. So you add the line that you just created, and if that happens to be a line that is supposed to be repeated, then you can add that again. So then you just have 2 of them. Works perfectly fine. No problems here. Bad omen for part 2? Maybe. Who knows? From that, so after you've done that, you can make the same kind of changes here. I just have a slightly more sophisticated way of getting my pairs between galaxies, which is the combine pairwise function. So all that does is it goes through the indices, and then for the second item that gets paired up with it, it only considers all the elements after the current element in the list. So that means you don't have duplicates, and you also don't have the same galaxy paired with itself. This is also something that I only did after I handed in my solution. My initial solution was also just kind of let's do all the pairs, and if I already have the pair in my list, we'll just continue. Or we'll skip over. But yeah, with that, yeah, you kind of end up at a similar solution. But this, of course, requires you to actually transform the input string, like actually blow it up the same way as it is in the input.
Yeah, this I can just add that actually I like your solution because it's explicit. Sometimes especially in inventive code puzzles, you can do some hacks. Okay, let's, I don't know, do some be luck and use this thing that we can divide by 2 and the distance is the same. But in general programming, I would prefer doing it more explicitly and building the pairs once to have this set of pairs.
Oh yeah, in that way, I think it's I was actually kind of happy with the way that I ended up doing this. Oh, and by the way, we can also just briefly look at the shortest path implementation, which I just defined as existing for pairs, so I can make this slightly shorter, which you'll see looks exactly the same as Sveta has it implemented. It's just the absolute distances between the x and the y coordinates. So nothing crazy here, with a little note that this is indeed the Manhattan distance. Max says, I did expand my strings as well. Luckily, I inserted commas instead of periods, mostly for debugging, so part 2 still worked well by counting the commas in the way. I'm very curious to see. That's very, very interesting. Yes. Herbert says, by expanding space, I contracted time, which makes my solution very fast. Almost acausal. All right, sure. Okay, well, let's see if either of our solutions is somehow better suited for what will come in part 2. I'm sure it's going to be a huge surprise. Yeah.
But luckily, we can still use this Manhattan distance and not avoid counting galaxies.
Hopefully, not everything will have to be thrown away. That's already a win in my book most of the times. So, we are ready for part 2. The galaxies are much older and thus much farther apart than the researcher initially estimated. Now, instead of the expansion you did before, make each empty row or column 1 million times larger. That is, each empty row should be replaced with 1 million empty rows, and each empty column should be replaced with 1 million empty columns. In the example above, if each empty row or column were merely 10 times larger, the sum of the shortest paths between every pair of galaxies would be 1030. If each empty row or column were merely 100 times larger, the sum of the shortest paths between every pair of galaxies would be 8,410. However, your universe will need to expand far beyond these values. Starting with the same initial image, expand the universe according to these new rules, then find the length of the shortest path between every pair of galaxies. What is the sum of these lengths? Now, Sveta, I can tell you right away what happened for me. For me, this is what happened. If I took my naive solution and I just made sure that I introduce 1 million items every time, I very quickly, apparently during one of my list allocations, just run into the point where I have more than 2.1 billion items in a list, which just blows up in my face, and I can't really do anything anymore. So clearly, my solution had a little bit of trouble in this regard. And I think that if we go back to your slides here, that maybe your approach was slightly more scalable. So I'll just open that one up here.
Yeah, I think that the rule of inventive code, if you can do math, try do math first. Because probably it will save you in the second part.
Oh, yeah.
That's something I learned from my experience with inventive code for sure. Yeah. So talking about part 2, when we have a different expansion, when we have 1 million, or let's consider the provided example 10 columns instead of 1, we need to change the number of columns that we add to each coefficient. So it's like when we are calculating the new coordinate, x coordinate, for instance, for the galaxy, now we need to add x delta multiplied to something, because we have just more columns added for each one. And then I also checked the discussion in Kotlin Slack afterwards. There was this discussion that there was this mistake when you don't remember to add this -1 to expansion coefficient. And I also did it because I was, you read the part 2, you change the solution. It's like, oh, it's super easy. You change something and you're like, it's like, I'm lucky. You press and see without checking first the provided values for sample input without doing anything. I was okay, let me just change one thing and see whether I'm lucky. And it's like, no, you're not lucky. Try, do the right way, return, check your sample data and see whether your change solution works for it. No, it doesn't. Why? Yes, because you need to add 9 columns, not 10 columns extra. So that's why you need this -1. And in the slides, I explicitly emphasize, okay, this one renamed, and we are adding this coefficient -1 or x -1 more columns. So that's how our new coordinates changed. And yeah, this is just change that we need for part 2, and we have very nice solution where we can even provide this expansion coefficient as an argument, and provide it different. Yeah, we can go back to code and see that we can say, okay, let's run all our sample input, real input, and we just change the expansion coefficient that we provide, and here we can provide 10 or 100 to make sure that it indeed corresponds to what was given us in the sample input. So that this was helpful. So in this regard, this solution doesn't need to be changed much. It's like it's this nice days when you just do something small and you're happy. It's like, okay, this day is done. This was all solved.
It is very elegant having this, and you will be shocked that my part 2 takes a very similar approach, because my regular approach doesn't work. So just like you did it, I just grab I still keep my algorithm around for counting empty columns and empty rows, and then for each of my points, I'll take a look at, and actually I just realized that I can make this calculation. I can move this in here, so that's slightly more efficient. I'll go through all of my elements. If they are a galaxy, in my original picture, I'll count all the empty columns to the left. I'll count all the empty columns to the left, all the empty rows above it, and then I'll create the galaxy at these new indices. Now, actually, you'll notice that my code looks slightly different than yours, because I had a slightly different intuition that that doesn't need this like off by 1 thing. It's the same. Obviously, it's the same code. Like, it's just this term expanded, right? Like if you were just to like multiply this in, you would just get like x plus x times x delta minus x delta, and then you could reorder these like so, and then that's the same term. The reason why I had this intuition for myself was, I was like, okay, what I'm doing is I'm replacing something, right? So the first thing I have to do is all the columns that I will insert an expanded version of, I'll have to remove them. So I'll remove all of them. I'll remove like 5 or 6 columns, and then I'll remove the same number but broader in the same direction. So this is how I expanded this term. And that helped me. I think that's what helped me avoid having this off by 1 error, just because I slightly looked at the The problem is slightly different. Apart from that, it's the exact same approach. It's just that I create my my locations using this wonderful flat map function, because I have two maps, or I have a map inside my map, which maybe generates a galaxy or maybe generates nothing if it's not a galaxy, and then we can do the exact same code as before. Or combine them pairwise, shortest path, too long. Too long is important and can actually be done very late in the processing chain. It's only before the sum that you need to convert to long. Everything else stays within int range. And then you get the final result.
So you do all calculations in int range.
Yes, I do.
It's like I'm lucky.
Yeah. Well, no, it's like I think you can actually estimate this in your head, and you can kind of convince yourself, because your input has, like, let's say 8, but for purposes of craziness, let's say like it has 20 empty columns and empty lines, and each of those get expanded to 1 million, so you'll have something slightly above 20 million in each direction. And if you go through the diagonals or through the Manhattan distance, that'll be 20 million plus 20 million. So you'll have something in the range of 40 million for each shortest path. So this is something where you can probably convince yourself rather quickly that for the input, that is okay. It's still probably a little more assumptions than you would like to make while you're exploring the problem. It is definitely the easier way to just turn all integers
sometimes
into long.
It's like let's use long from start.
Yes. I think that's probably the smarter move. Unless, of course, as Peter says here, the kicker is then when even long is too short. But usually when that happens, I think you'll have to look at the Chinese remainder theorem or something else, where you're starting to do funky modulo arithmetic, and your big int solution might not survive regardless. Yeah. Jonathan says, I had to write the whole just grab the coordinates and add the offsets when part 2 was unlocked for me. We're in the same boat here, Jonathan. I did the same approach, because the one thing that I've learned is I never know what happens in part 2. So sometimes I'm okay with not trying to anticipate too much. Again, if part 2, like Sveta has said, would have actually been what are the paths avoiding other galaxies, then calculating the offsets with the slightly more brain power would have not really brought me any closer to the solution. But of course, good instinct on your part there. Yeah. But especially it's nice to see here that the off by ones were certainly quite popular with folks here as well. I am quite curious because Max said they entered commas instead of periods mostly for debugging, so the part 2 still worked well by counting the commas in the way. And I'm very curious, does that mean, Max, if you are still here and want to elaborate on this, does that mean that you're actually counting 8 to, let me once again ask my good friend, because I can't pronounce this number. Are you iterating 840 billion commas? Is that actually what you're doing? How long does that take to run? Okay, no, you're not doing that. Okay, you're taking a different approach. Okay. Ivan says, in my humble opinion, this year's challenges are much more difficult than last year's. They seem to have a strange fluctuation where some of them are quite hard or not very approachable, and then others are a lot more. Damir says, I am guessing he means each comma is just like 999. Okay. Oh, so they counted 10 commas and then multiplied it by the expansion factor. Okay. All right. That's probably a slightly more... it's probably a slightly better... That's actually a really nice idea. So if I'm understanding this correctly, I'll try to super briefly visualize this. Is saying, rather than saying, okay, I have an empty column here that I'll blow up to 1 million, what I'll do instead is I'll turn all of these into commas, so I'll know that this is an expanded column, and then if I trace this path, for example, that goes through these, then I'll get, well, I'm off by 1. you know, if 9 was over here, you know what I mean. Then you would take into account, these would actually not be commas, but yes. Well, now I'm off by 1 again.
No, but I mean, like, yeah, the idea is really,
Yes.
really how you emphasize that you replace the empty row or column with commas, and then you count these
Yes.
commas. It's actually a nice idea.
That is quite convenient. And I suppose because in the Manhattan distance you're doing this like, well, I'm just curious now if well, you still no, never mind. So you still have to traverse the same number of commas, regardless of whether you go this path or the other path. That's a very nice solution, and I think that's also very like visual. So that's a very cool move. Yeah, Peter says there's the two hardest problems in IT: cache and validation, naming off by 1 errors. I didn't expect I was gonna encounter my off by 1 error for today's problem in PowerPoint of all places. But I mean, hey, yeah. That's a really cool move. Awesome. Yeah. And luckily this number does fit into a long, which is nice. Very cool. So how were your overall feelings on today's problem, Sveta? Would you categorize this as a harder problem, or as Rebby said?
No, I think I was lucky.
As a yeah.
I think I was really lucky, especially with the second part. So I got easy day. I remember that from last year. It's like sometimes on day 6 or 7 you have like, oh, what's going on, and then it's like it's kind of relaxation again. Like, okay, this one is easier.
Yeah. Let's have a look here. We also had a couple of other points. Yeah, exactly. So your luckiness was definitely shared by some viewers as well. They got lucky by keeping sets of the lines, and then when you count the distance, yeah, you just add the expansion. So part 2 was already ready. Smart move, good move. Always great. And as we saw, I assume Patrick is no longer watching because they do not want to get spoiled. But yeah, you don't actually have to do stuff like A*. All you need to know for this problem is a little bit of Manhattan distance. Yeah, which is quite delightful. Sveta, do you have any predictions for what might happen in the next couple of days?
Not really.
No?
But I can predict what happens in 13 days or in 14 days. Disaster. I mean, like, you can spend the whole day solving the problem. And then it's like, where's my life?
Yeah.
I miss life.
That's very true. Oh my. 1 minute sound for those who did Dijkstra's. Yeah, that would be slightly overkill. But again, if the second part of the problem could have looked different. I'm personally still looking for something where you recursively traverse some kind of data structure. Maybe some tree structure. We haven't seen like the parenthesis like equality, so checking whether like parenthesis balance or brace balance. Olaf, who already has a pretty good track record with his predictions, says some int code computer, so some kind of I guess interpreter for an assembly language type thing, which would be interesting. Max says that for today they feared the traveling salesman problem for part 2, which of course casually solving an NP complete problem on day 11, no biggie. Ivan says that there are probably still going to be tasks with Dijkstra's algorithm or Floyd's algorithm or something similar. Yeah, some kind of pathfinding is surely around the corner. But the question is, I feel like they wouldn't stack multiple graph-like problems one after the other. I feel like tomorrow would be something else, because we've seen the puzzle map yesterday, and then we've seen, or like the labyrinth yesterday, and today we've seen our galaxies and distances. So I'm very curious. Some used recursion for day 9, the extrapolation problem. Yeah, and I mean, if you're funky, and you can always use whenever there's a loop, you could just use a tail recursive function instead. That also works wonderfully. So we'll see. No matter what, I'm sure it'll be interesting.
Less than 11 hours. And the new puzzle appears.
Yes, this is always the beauty about the calendar, is I finish my day with with the stream, then I look at the calendar and I'm like, oh my, it's probably time to go to bed almost, so that I can be well rested for what's next. So I guess we will find out tomorrow, and of course I already wish everyone best of luck with this. If you do want to join the live stream tomorrow, which will be our commemorative, 12th live stream, it will be the final live stream that we will be doing for this year. So if you are like Olaf and you need someone or want someone to read the story of the actual problem to you in the evenings or whatever time it may be, then make sure you tune in again tomorrow as well. Reminder again that we do have on the Kotlin YouTube channel at the usual time slot the Kotlin and WebAssembly live session together with Salim, who you've already maybe seen on one of the previous streams, celebrating and showing off Kotlin for WebAssembly and seeing maybe also what's new in the alpha version of Kotlin WASM. And we'll be about an hour later than usual, but we will be back. Wonderful. Great. So with that, I think it is time for us to wrap up. Sveta, thank you so much for joining us today for this cozy hour of puzzling in Kotlin.
Thank you. It's great. Advent of time is always great, but it's also Christmas time, you know. You can go to Christmas markets, you can enjoy Christmas activities. So It's all around life, not only programming.
And I think starting with the 13th of December, I'll have to catch up a little bit on a couple of those Christmas activities when the streams are out of the way. Yeah. Thank you so much, everyone, as usual, who decided that they would spend their Monday with us doing a little bit of Kotlin puzzling. If you were part of this session of live streams for a little bit longer, and you've seen the cool things that we've seen with Kotlin notebooks on, I think it was day 5. If you haven't, go check that out. You might really want to tune in again tomorrow, because maybe we'll have a special guest who can show us a little bit more about what Kotlin notebooks can do. So thanks for sticking around. Enjoy tomorrow's puzzle, and have a nice Advent of Code. Take care, everybody. See ya.
See you. Bye-bye.